For our Mike 203 project, we created the Ascension rover. We took inspiration from NASA's Perseverance and Curiosity rover when creating Ascension. Our rover uses a rocker bogie mechanism along with our traction wheels to navigate the rough terrain of Mars. The suspension is connected to the chassis using a free-running clearance fit so that the suspension could adapt to the rocky Mars terrain. The hull and shaft diameter tolerances are 200.150 mm H9 and 199.830 mm D9. The wheels are connected to the suspension using a free-running clearance fit so that the wheels can rotate. The hull and shaft diameter tolerances are 60.074 mm H9 and 59.900 mm D9. This is our robotic arm. Our robotic arm was created with 3 degrees of freedom for it to have a wide range of motion. It could rotate around the chassis body and reach the ground to pick up potential objects. The robotic arm is connected to the chassis using a free-running clearance fit to allow for rotation around the y-axis. The hull and shaft diameter tolerances are 624.757 mm H9 and 624.575 mm D9. The robotic part, or the bottom part of the robotic arm, is connected to the base chassis using a free-running clearance fit so that it can revolve around the x-axis. The hull and shaft diameter tolerances are 250.115 mm H9 and 249.830 mm D9. The top part of the robotic arm is connected to the bottom part using the same clearance and diameter tolerances. The gripper is connected to the rest of the robotic arm using a free-running clearance fit to allow for rotation. The hull and shaft diameter tolerances are 93.88 H9 and 93.686 D9. We also added an antenna to our chassis so that it can effectively communicate with ground control back on Earth. To get the best signal, we connected the antenna to a ball joint which has a rigid mate to the chassis. The satellite is connected to the ball joint using a free-running clearance fit. The hull and shaft diameter tolerances are 120.087 mm H9 and 119.880 mm D9. The satellite is connected to the chassis using a locational clearance fit for a rigid mate. The hull and shaft diameter tolerances are 30.021 mm H9 and 30 mm D9. For our camera, it was essential for it to see at all angles around the rover. The camera is connected to the chassis using a free-running clearance fit to allow for rotation. The hull and shaft diameter tolerances are 150.025 mm H9 and 150 mm D9. We also included 2 power sources in our project to make sure that the rover runs for as long as possible. Our rover is equipped with a multi-mission radioisotope thermoelectric generator and 2 solar panels on its side. The MMRTG is connected to the chassis using a free-running clearance fit. The hull and shaft diameter tolerances are 500.155 mm H9 and 499.770 mm D9.